Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we're going to talk about quartiles and calculating quartiles. And there's quite a bit we need to cover, so let's jump right in. The first thing we want to talk about is percentile. Just exactly what is a percentile. So the kth percentile, which we use P sub k right here to denote it, is the kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. We hear these all the time when we're talking about test results, like your SAT test results. You scored in the 90th percentile or the 78th percentile. Or now that I have kids and I take them to the doctor frequently or once a year at least for their annual, I hear a lot of times that they are in the 90th percentile for their height or the 90th percentile for their body weight. And basically what that means is that they are taller than or the same height than 90% of the individuals that height is taken. If they're in the 90th percentile for their height, or if they're in the 90th percentile for their weight, then they are the same weight or bigger than, way more than 90 percentile of the individuals that are taken, their body weight is taken at their age. And so basically, it just means that your k% of the observations are less than or equal to that value. Hopefully that makes sense, okay? Let's look at an example. So example, Jennifer just received the results of her SAT exam. Her SAT mathematics score of 600 is in the 74th percentile. What does this mean, okay? So basically, it means that she scored higher than or the same than 74% of individuals who took the test. So it says it means that 70% of SAT math scores are less than or equal to 600, and 26%, which is 100 minus 74, 26% of the scores are greater than that score of 600. So 26% of the students who took the exam scored better than Jennifer. And then she scored better than or the same as 74% of the individuals that took the exam. And so we need to know what percentiles mean in order to talk about quartiles. So quartiles take your data set and divides it into 4 equal parts, okay? So you have a first quartile, second quartile, third quartile, and a fourth quartile. The first quartile, which we use is Q with a subscript of 1, Q1, it divides the bottom 25% of the data from the top 25% of the data. And so therefore, the first quartile is equivalent to the 25th percentile, all right? The second quartile divides the bottom half of the data from the top half of the data. So it's the 50th percentile, which is also equivalent to the median, so the middle of the data. The third quartile divides the bottom 75% from the top 25%. Alrighty? And so here is a visual representation of what they look like. So if this is your data, 25% of your data is here, and that is Q1. Then another 25% is here. This is Q2. Another 25% is here. This is Q3. So we say the bottom 25 from the top 75 because all three of these together would be 75. All right, and so these are the steps for finding the quartiles. There are 3 steps. First thing you have to do is arrange the data in ascending order from smallest to biggest. And then the second thing you have to do is find the median or the second quartile. The median is also your Q2. And then you would divide the data set into 2 halves. And the median of the first half will be your Q1. And the median of the second half will be your Q3. Okay? We're going to do an example of this. So in this example, the Highway Loss Data Institute routinely collects data on collision coverage claims. Collision coverage insures against physical damage to an insured individual's vehicle. The data below in the chart represents a random sample of 18 collision coverage claims based on data obtained from the Highway Loss Data Institute. Find and interpret the first, second, and third quartiles for collision coverage claims, okay? So these are 18 random claims, the amount of 18 random claims that was obtained from the Highway Loss Data Institute. And what we want to do is we want to find the quartiles for this data, for this sample data. So the first thing we have to do is put all of these in order. So I'm looking for my smallest, which I see is 189. And then the next smallest, I believe, is 370. No, my smallest is 180. I'll take that back. Then 189, then 370, then 618 and 735. So you will have to go through and put these in order, which I have already done in this chart right here. I have put them in order, and there were 18, so I broke it into 2 halves. I put 9 up here and 9 down here, okay? These are the first 9 data points. These are the second 9 data points. Now, the first thing we will want to find is the median, okay? Now, in order to find the median, we have to find the middle number. Now, remember, when there is an even number of numbers, in order to find the middle number, you will have to take the average of the 2 middle numbers. So when there's an even number of numbers, there are 2 numbers in the middle. So my 2 numbers that will be in the middle will be my 9th and 10th number. So that number here, the number that's at the end of this first row, and the number that's at the beginning of this second row. And remember, that's how you find the median. You take the average of the 2 middle numbers. So for my Q2, I would add up this 1657 and this 1953 and divide it by 2. Okay. If you add 1657 and 1953, you get 1805. And divided by 2, you get, oh no, I take that back. You don't get 1805. 1805 is your final answer. Let me erase that up here really quick. So 1805 is your Q2. But when you add the 1657, let me let you know what I get. When I added the 1657 and the 1953, I got 3610. And then when you divide that by 2, you get the 1805. So 1805 is your median, which is your Q2, which is the value that separates the first half of the data from the second half of the data, okay? So that is your middle value. Now we want to find Q1 and Q3. So Q1 is going to be the median of the first half of the data. So my first half is in the top, and there are 9 numbers in my first half. So the middle number is going to be this number right here, the 5th number. And actually, it's going to work the same for both those two, because if you were to cross out the numbers, and this is in white, if you cross out each number to you in pairs, till you're left with one number in the middle, it ends up being that 5th number. So 735 would be your Q1, and 4668 will be your Q3, because that's the median of the bottom half. So you take the median of the top half to give you Q1, and the median of the bottom half to give you Q3. So your Q1 is the 735. That is the number that separates your bottom 25% of data to your top, from your top 75% of data. Your Q3, which is 4,668, is the number that separates your bottom 75% from your top 25%. So what does that mean? That means that 25% of the claims are less than or equal to $735. And Q3 means that 75% of the claims are less than or equal to $4,668. What does Q2 mean? That means that 50% of the claims, half of the claims, are less than or equal to $1,805. So that is how you will calculate your quartiles, and that is what the quartiles mean. All right, another term that we need to know about is the interquartile range, and this is the range of the middle 50% of the observations in the data set. So instead of taking the range of the full set, it gives you the range of the middle 50%, which is the range between your Q1 and your Q3. So in order to find the interquartile range, you would do Q3 minus Q1. So if we wanted to find the interquartile range of the example that we just did, we would do our Q3 minus our Q1. So the collision data we just calculated the quartiles for, The Q3 was 4668. And the Q1 was 735. And this is our IQR. We use IQR for interquartile range. Well, that ends up being 4668 minus 735. That ends up being 3933. So our IQR, our interquartile range, is 3933. That means that the range between your middle data from your 25% to your 75%, that range is $3,933. Now, this is a measure of spread. So like your standard deviation and like your range, this is another measure of spread that you can use, okay? Now, there are some standard rules as to when we use this versus using standard deviation. And I believe I have a chart here. Yeah. So this chart tells us like which measures do we report. And this all based on the shape of the distribution. So if our distribution is symmetric, then the best measures to use are the mean and the standard deviation. But if our shape is either skew left or skew right, then the best measures to use would be the median and the interquartile range for our dispersion, okay? So these are our standard rules. If we have symmetric data, the best measures to use will be our mean and standard deviation. And if our data is either skew left or skew right, we'll use our median and our interquartile range for our measure of dispersion, all righty? And so in that case, that's why you would have to know how to calculate your quartiles, because you got to know how to calculate the quartiles in order to find the interquartile range. And that is all I believe I have, yes, for this video. If you have any questions, please put them in the comments below. If not, I will see you all in the next video where we're going to talk about outliers. Alrighty.